The Nesting and Fabrication Extension in Fusion 360 extends its manufacturing capabilities to support a variety of industry workflows for fabrication. In Fusion 360, manufacturing tools are fully integrated with a full suite of design functionality. So, to reduce model preparation time, Nest Preparation in the design workspace automatically detects different nestable parts and filters them out based on your preferences. This is especially helpful when working with a full assembly. It also means you can import native CAD data without needing to go through a lossy DXF translation process, whether you're working with your own data or with customer parts. There are more granular controls for individual components if you're working with non-sheet metal parts and need to make adjustments accordingly. Now over in the manufacture workspace, you could get to nesting right away, which is great for quoting and material ordering. But there are a couple advanced tools I would recommend using to dial in your nesting settings. First, Component Sources shows a table or tree of all the current components with additional information for components that were included based on the nest preparation. It includes different views of the part, including its nestable shape. You can also set shape-specific settings here, like the quantity of the part to be nested and whether or not the shape settings are bound to the material, which we'll get to in a minute. You can also remove parts or combine jobs for better material usage and overall efficiency, saving time on the nesting process itself too. For example, I can add in a different configuration of the snowplow to nest as well. Next, the Process Material Library gives a place to manage and store materials used in the nesting process. Materials contain overall material data, including nest settings to help optimize each nest based on material or manufacturing method needed for that material. Packaging inherits those material settings, but can have different dimensions and costs. Process materials can be saved as presets as well as loaded in from existing presets, making it easy to share with your whole team and help ensure best practices and smart defaults are used effectively. Now it's time to create the nest study. Here I can independently set how many of each assembly I want to nest, review all the shapes to be nested, including a graphical preview, review the packaging materials used, dial in overall nesting study parameters like calculation time and remnant optimization, and then customize the output. Include stock will create some helpful downstream assets for when you start creating toolpaths, so I'll make sure that's checked. Click OK, and the nesting algorithm will start nesting given all the specifications from the materials and the nesting dialog. If you don't go through the process of setting up custom materials, Fusion 360 will automatically create materials to accommodate all the components you want to nest, using reasonable default values to nest all the shapes. This makes it a quick and easy way to preview nested results, especially again for quoting or material ordering, but component sources and process materials offer more control and customization for production. So now that there are some nested results, you can click through each sheet to see how the nest turned out, and visually, things are looking pretty good. But what if you want more detail? You can select any number of sheets, nests, or studies, right-click, and select Compare to see a quick view of some key metrics and how they stack up across nests or individual sheets. This view is configurable, so I can pick nests or sheets to compare, change the types of metrics I'm seeing, and change the view as well as the component colorization within each sheet. This is a great way to get quick information on cost, efficiency, and total material usage for quoting, or again, making material purchasing decisions. So parts are nested, things are looking good in the compare view, but what if my design changes? Let's head back into the design workspace and change the dimensions of the truck mounts to meet the new specifications. Full CAD integration is one of the biggest benefits Fusion 360 has to offer, since you can make updates here and can again avoid translation or data management processes. All there is to do now is update all the flat patterns, head back into the manufacturer workspace. And one of the best parts is Fusion 360 recognizes which sheets contain components that were updated, so you know which ones need to be regenerated. No need to regenerate the whole study, or even worse, start from scratch. All you need to do is right-click on the marked sheets and pick Regenerate. Now that the nests have been updated with the new specifications, reports offer a more in-depth and printable way to view nesting metrics, including the nest sources and packaging and their parameters, nested sheets, sheet part summaries. Reports also offer configuration through report templates, accessible from the drop-down at the top of the sheet, and sections can be shown or hidden to adjust the report length. To share this out, you can save the HTML file itself or print to create a PDF or paper copy. The other huge benefit to full integration with Fusion 360 is access to the CAM functionality for toolpath creation. You can create a setup directly from the nested sheet, which automatically imports the stock model that was created during the nesting process. There's no need to manually create or manage that stock. There are tools to support different cutting options like waterjet, laser, or plasma cutters that can be created ahead of time and managed in the tool library, or quickly created on the fly like I'm doing right now. When it comes to the toolpath itself, our 2D profile strategy has lots of options for control, including tabs, but the real magic is in the contour selection. I'll quickly hide the stock body under the nested sheet, and then pick the face of one part to select all the contours of that part. Then all you need to do to select all the other contours is enable Select Same Plane Faces, which will grab the contours of every other part on the sheet, which saves a ton of time over selecting individual contours manually. There are also filters built in to help support different processes, like cutting inner contours first to avoid part shifting during the cutting process on a waterjet, for example. In the other tabs, there's control for the heights the head retracts to between passes or toolpaths, compensation control, and lead in and lead out control. Of course, all the standard benefits of Fusion 360 manufacturing apply, like tooltips, which give detailed information on each toolpath and option, and derived operations. Derived operations create a new toolpath while maintaining selections made in the source toolpath, so all you need to do is change the loop selection to outer loops to get the rest of the parts programmed. One of the downstream assets I mentioned earlier is the sketch line that's automatically created to help with remnant cuts. Just select the sketch line when creating the 2D profile toolpath. When I do this, I like to change my sideways compensation to center, and now you get a nice square remnant at the end of the cutting process. Once your toolpaths are created, verify them with a quick stock simulation to see a preview of how the machine will move during the cutting process. Any gouges are shown in red, and you can see how the tool moves and retracts across the sheet and make any adjustments before running the parts on the machine. Last but not least, we have a huge library of free and fully customizable post processors to get code to your machine. You can filter the posts by capability to see all of our cutting posts and find one that works for you, or search our online post library for even more options.